Okay, so now we're going to take a look at the definition of sine and cosine. Okay, so from geometry in a right triangle, if you remember, the sine and the cosine were defined as, and we know that the sine is the opposite side divided by the hypotenuse, and the cosine is the adjacent side divided by the hypotenuse. And if you remember when we reviewed, we went over SOHCAHTOA, and that's pretty much what we just did. Okay, so now we're going to look in terms of trig what the definitions for sine and cosine are. So if you look at the unit circle on the right-hand side here, you can see that we have angle theta in here. Okay, it could be any angle, all right, and it's drawn in standard position. So if we were looking for the sine, now when we look at the sine of theta here, we know that that's the opposite side over the hypotenuse. Well, we're in the unit circle, and we know that in order to get to this point, we have to go over x units, and then we have to go up y units, and that's where we get that xy coordinate from. So in the unit circle, the hypotenuse of that right triangle is always 1. So we know that this is going to be over 1. And the sine is the opposite side, which ends up being the y value. So the sine of theta is always just going to be whatever the y coordinate is of that point on the circle. Okay, now when we look at the cosine, well, we're going to do the same thing. The cosine, however, is equal to the adjacent side over the hypotenuse. Again, the hypotenuse is always 1, but the adjacent side is the x value. So that means that the cosine of theta is always equal to the x coordinate. Now remember, this is only in the unit circle, okay, because the hypotenuse must be equal to 1. Oops, I spelled circle wrong. Put an extra L in there. Okay, so it has to be that coordinate, that xy coordinate, the cosine is always the x value in the unit circle, and the sine is always the y value. Now, just the same as xy is alphabetical, xyz, all right, so the x and the y come in that order in the alphabet. Cosine and sine are also alphabetical, so that's just a little way of remembering which is which. Okay, and here's the definition here that we just went over. The definition of the sine and the cosine functions: for an angle in standard position whose terminal ray passes through the point on the unit circle only, the y coordinate is always going to be the sine, and the x coordinate is always going to be the cosine. All right, so let's look first in quadrant 1 only. Okay, so it says to determine the exact value. All right, now if you were just to plug these into your calculator, you would not necessarily get the exact value. So I'm going to make sure my calculator is in degree mode. And then I'm going to type in the cosine of 30. Well, the cosine of 30 is equal to 0.866025, blah, 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 blah. Okay, so that's not an exact value. That's rounded at some point, however many decimals fit on your calculator. Okay, we want the exact value. So that means it's an irrational number. It's going to have to be represented as a radical. Okay, so the cosine of 30, what we would do is we would say, okay, well, the cosine of 30, this is my 30-degree angle. Okay, and I know that that means that this is 60 degrees, and I'm going to, from the last lesson, remember that opposite the 30 degrees is 1/2, opposite the 60 degrees is radical 3/2. And in this quadrant, everything is positive, right? We have x and y, it's positive, positive. Okay, so the cosine is the adjacent side. Now, if we want to look at what that coordinate would be, it would be the square root of 3/2 and 1/2. The cosine is the x value or the adjacent side. You can look at it either way. All right, so the answer is the square root of 3 over 2. Now, if you were to, in your calculator, go ahead and put the square root of 3 over 2, you would get that same 0.866025, blah, blah, blah. So you would know your answer is correct. All right, so let's go on to the next one. The sine of 45 degrees. So whenever we do this, whenever we're asked for an exact value, we're always going to draw our reference triangle. So 45 degrees is here, which means this is a 45, 45, 90, which, if you remember from last week, I told you this was something you have to memorize. This is going to be the square root of 2 over 2, both sides. Okay, so whether you're looking for the sine or the cosine, they're both going to be the same. However, just for argument's sake, when we get to the other quadrants, you're looking here at the y value, okay, because the sine is the y value, cosine is the x, the sine is the y value. So, or the opposite side, opposite over hypotenuse. So that would be the square root of 2 over 2. Okay, so going on to the sine of 390. Well, 390 doesn't fit within our 360, so we're going to have to find a coterminal angle. So first I'm going to subtract 360, and I get 30 degrees. And I'm going to go ahead and draw my 30-degree angle, which I kind of already drew. I did already draw over there, but I'm going to do it again. This time I'm looking for my sine, which is the opposite side. So the opposite of the 30 is 1/2. That coordinate here, we remember, since this is radical 3 over 2, is radical 3 over 2, 1/2. That's what we were doing last class, just coming up with the coordinate. So this is really the same lesson it would have been if we were still in school, where we're taking it one step further and showing that because the sine is that y value, it's going to be 1/2. Okay, so now there's some practice questions to do, so you can go ahead and do those.